Now we've got a binomial multiplying with a trinomial. We're on page 108. And this really isn't any different. It's just got an extra column. We're going to again start with a picture. We're going to start with a rectangle. And we are going to call this side 3y minus 4. And we are going to call what would be considered the length, I guess, the terms of this trinomial, y squared minus 5y plus 7. And we're going to go ahead and we're going to find the area of our 6 little boxes. So 3y times y squared is 3y cubed. Minus 4 times y squared is minus 4y squared. Minus 3 times minus 5y is minus 15y squared. This box right here would be positive 20y. This box would be 21y. And finally, this box is going to be a constant, just minus 28. So now we need to simplify. We need to write it in standard form. And I want you to look at something that is kind of cool here that happens. So if we start with this box right here, we don't have any other y cubes. So we can go ahead and write him down. But then, if you kind of notice, if you look at the diagonal, this guy going with that guy, this guy going with that guy, these are like terms. So we can combine them. We've got minus 4y squared and minus 15 more of those negative y squared. So we can just go ahead and write minus 19y squared after combining our like terms. Similarly, this diagonal, 20 plus 21, these are both positive, so that's going to give us a 41y. And then finally, the constant on the back end is minus 28. And this is our simplified product of the binomial and the trinomial as factors. So we're going to go down here and we're going to do it without writing a picture. And we are going to distribute, double distribute again. The 5m, let me just go ahead and write this out, is going to be multiplied to each term in the trinomial. And we are also going to multiply the negative 1 by each term in the trinomial. I should have started over to the left a little bit more. So we have a little bit longer problem, but it's exactly the same process. And now we're going to distribute. So that's going to give us 10m cubed plus 15m squared minus 35m to the first minus 2m squared minus 3m plus 7. And surely there are some like terms in here. So do we have any other m cubes? I don't see any. But I see some m squares here and here. Don't forget this sign goes with this too. So if I've got 15m squares and I take 2 of them away, that leaves me with 13 of the m squares. And of course the 10m cubed came down as our first term. Okay, so that takes care of those guys. And now I've got, what do I have here? I have an m to the first power and more m's to the first power. And they're both negative. So that's going to give me minus 38 m to the first power. And finally, the constant on the back end plus 7. So you guys try B on your own and see what you come up with, and we'll compare answers when we get to class. All right, I want to keep going here, and just kind of maybe this video might be just a little bit longer, but it'll get us through this section. On the very next page, example number 5, we now have 3 binomials to multiply. Well, there is no way to multiply 3 numbers together at the same time. If I told you to multiply 3 times 4 times 5, you'd have to pick 2 to start with. You can't just multiply 3 numbers together. Well, it's the same thing here. We're going to choose, at least I'm going to choose for us, these 2 factors to work with first. And we're going to work these just like we did on the other page. I'm going to start over here, and I'm going to take this m and distribute him to the m minus 2, the other factor. And then I'm going to take the positive 2 and distribute him. And now this is all still inside my brackets. When I clean this up, I've got one more multiplication piece to do with this guy right here. So this guy still inside the brackets becomes m squared minus 2m plus 2m minus 4. And all of that is going to do one more multiplication as soon as I clean this up. Because I do have some m's to the first power, a minus 2 and a plus 2, they go away. So now I'm left with m squared minus 4 times m minus 3. And we've got to go through the whole distribution process again. So I'm going to take the m squared and multiply it times the other factor, which is m minus 3. And I'm going to take the minus 4 and multiply him times m minus 3. And I'm going to clean it up. So I get m cubed minus 3m squared minus 4m plus 12. And if we inspect our terms, we'll see we don't have any terms that are alike. So we are in standard order with the variable m, exponent of 3, 2, 1, and our constant. So this is our cleaned up answer. I'm going to leave B to you, but I do want to come down and point to number C. This now is a mix of multiplication and addition problems. You can see that these two binomials are not multiplied together. They are subtracted. So you need to do the distribution of the ghostly 1 to get this guy out of the grouping symbol. And now you just need to collect your like terms. You've got positive 3x here and negative 5x there. That leaves you with negative 2x, and a plus 2 and a minus 7 is a minus 5. And that's your answer. There was no multiplication except the distribution of the negative 1. So these problems, D and E, have some of both. They've got distribution and multiplication, but they've also got subtraction. So that's what you want to look at and be careful for as you're doing these problems. Okay, thanks. See you next time.